When your goal is to control airflow, you want to compartmentalize the building as much as possible. And the purpose of compartmentalization is to isolate connecting spaces and minimize the impact of the stack effect. You want to disconnect building spaces between the foundation and occupied spaces above, between the roof and occupied spaces below, disconnect floors, rooms, and connecting corridors. You want to isolate your continuous vertical paths, like stairwells and utility shafts. Airtight doors are an asset here, and here's the constant reminder to seal all penetrations. If you have access panels to electrical boxes and telephone equipment, install airtight covers. Elevators move lots of air, so isolate elevator lobbies from elevator shafts. They often run from the ground to the roof, and the mechanical rooms are typically located on the roof or a high point in the building, so it follows that airtight elevator doors are essential. By the way, sloppy elevator installations can pull airborne contaminants along with stack-driven air through the building. Parking garages are one such source of contaminants. A good design is to separate the elevator lobby from adjacent spaces with an airtight doorway. Hidden plenums should always be isolated. If plenums are concealed behind a suspended ceiling, remember these ceilings are not considered airtight, so disregard suspended ceilings when you're designing air barriers. And remember to isolate and seal off return air plenums from occupied spaces. Here's a checklist for identifying and isolating pollution sources. Because the stack effect and the mechanical effect pressures can transfer contaminants throughout buildings, you want to isolate the potential sources as the building is constructed. Garages are a major source of pollution, so prevent automobile emissions from entering the rest of the building. Isolate chemical storage areas and mechanical rooms. Other pollution sources include commercial kitchens, photocopy rooms, and lavatories. Entry lobbies should be isolated from the rest of the building because this is the place where doors open and close frequently, perhaps constantly. To minimize exterior air from entering, isolate lobbies with vestibules. Use revolving doors whenever possible, and use automatic closures on conventional doors. And if the lobby area has recessed lighting, it's important to air seal them, or you may be encouraging unwanted air and moisture to get into plenums and other spaces. When it comes to recessed lights, it's important to use IC-rated airtight recessed lighting. The interface between the ceiling and the light should be sealed using an airtight gasket or adhesive sealant. Remember, a thorough sealing job is necessary around plumbing penetrations between floors. Sealants and caulks should be fire-rated for the application, and often the sealants must be certified for code approval, so check the requirements to be safe. For more information, refer to Module 5, Building for Fire Safety. You want to make sure that vertical and horizontal paths are sealed to minimize room pressurization. Again, the idea is to compartmentalize as much as possible. Another benefit of air sealing here is that you'll also be contributing to sound control. With your HVAC air distribution systems, they should be both well insulated and airtight. This is another key place where air sealing results in reducing room pressurization. And when there are necessary functional penetrations, fresh air intakes, exhaust hoods, they should have airtight dampers to maximize air control through those types of systems. Wood-framed construction has its own set of do's and don'ts. CertainTeed has a companion DVD, The Art of Building Science, which contains information on airflow and air barriers. It's available from the CertainTeed Building Science Department. To summarize, remember, continuity counts. We can't say this enough. Effective air barriers require special attention at all penetrations. And here are the places where many problems can begin. Areas of discontinuance in the building, for example, roof decks and parapets, windows and doors, wall and floor intersections, at expansion joints. Wherever there are brick ties, there are penetrations, and at all facade supports. The list goes on, but attention to detail is key to maximizing air control and minimizing related problems.